Welcome everyone to today's training video. Today's training video is brought to you by Start Canada. In today's video, we're going to be going over how to deploy a web application using cloud-based services. Specifically, we're going to be deploying Moodle Learning Management System as our base application. And for cloud services, we're going to be using Amazon Web Services. So for those that don't know, Moodle is one of the most popular and largest learning management systems used by educational institutions around the world. It's a very robust platform. It is a very customizable platform. And it has many use cases outside of just educational institutions, being that it is so highly customizable. But the main value today is not Moodle itself. It is the exercise of understanding how we deploy a web application using cloud-based infrastructure. So in today's exercise, we are going to be using a lot of Linux commands as we deploy this using a Linux environment. Now, it's not expected that you understand each and every Linux command used. That's not the purpose of the exercise. The purpose of the exercise is to get the web application, in this case Moodle, into a deployed and functional state. Now, once you've done that a few times and you've practiced it and you feel comfortable with doing that using Linux, AWS, I would suggest that you go back, read through all the documentation that you will be provided today, and see if you can study and get a deeper understanding of the commands used and in what other context those commands can be used in. But for the purpose of this video, it's not necessary. So as we begin today, again, everything's going to be done in a very step-by-step manner, and I'm going to attempt to elaborate on a lot of things, explain a lot of things, with the assumption that there are people that are going to be watching this video that are not familiar with AWS, that are not familiar with Linux, that have never configured a database before, things of that nature. So I'm going to try to educate as I go through this tutorial, and I'm going to elaborate on each and every step as I go through where I feel it's necessary. But again, the value is just getting the app to a workable state, and then of course you can go back, watch this video again, and try to understand deeper sort of some of the implementations that we do today. So as we get started, a few assumptions. Assumption number one is that you have access to some AWS account of some form. Now, whether that be a Start Canada AWS account or whether it be your own AWS account, you need access to a AWS account, and you need to be able to access the infrastructure within the command console, as you can see here. And you also need the required permissions in order to, at bare minimum, be able to deploy virtual machines. In this case, EC2 instances, because we're using Amazon Web Services. So that's assumption number one, that you have access to an AWS account. Assumption number two is that you will have a terminal client of some kind to which you can access virtual machines remotely using SSH or Secure Shell. Now, you'll see on the internet that a lot of people typically will use PuTTY. PuTTY appears to be, or seems to be, the de facto standard for terminal remote virtual machine connectivity as a terminal client, which is perfectly fine. It's a very lightweight graphical user GUI-based terminal client that a lot of people use. But for today's video, I'm actually going to be using a different terminal client called MobaXterm. The reason being is just because it is a much nicer user interface, and it will be much easier to see via recording. so that you don't have to actually squint when trying to follow all of the Linux commands that I will be inputting. So for the purposes of this video, this is significantly better. And just in general, MOBA Xterm is a really great client. It's available for Windows, not necessarily available for Mac OS, the last time I've checked. But again, it's not necessary. You just need some terminal client of some kind. Now, you don't even need a graphical user interface, or a graphical client, I should say. If you're on Linux, you can use the Bash shell. If you're on Mac OS, you can use the command terminal. And of course, if you're on Windows, you can use PowerShell. You don't actually need a terminal client, but it makes things much, much easier. Okay, so with that, I think we can get started. Now, again, we're going to be deploying Moodle LMS in a very simplified manner. And by simplified, I mean that we are going to be deploying it as a monolithic application. Monolithic application meaning that both the web server, the application server, and the database are going to be tightly coupled into one virtual machine. Now, when you're building more robust systems, typically you want to decouple these different components. But again, the purpose of the exercise today is to get everyone just understanding how to deploy an application. As you become more comfortable with this, then you can figure out how to start pulling apart certain components into their own virtual machines, with connectivity between each and every component. But for today, we're going to have a standalone monolithic application. So first thing we need to do is we need to access the service that we're going to be using. And in this particular case, we're going to be using EC2. This stands for Elastic Computing. And all this is basically a virtual computer. Imagine software-generated virtual computers. Is a simplified definition of what a virtual machine would be. So in this case, we're going to click into EC2. Now, when we click into EC2, you're going to be brought to the EC2 dashboard. Now, when deploying an EC2 instance, a couple things that you need to consider. Number one is that you need to just consider, or at least remember, which region you're going to be deploying this instance in. So AWS has many data centers throughout the entire world, and of course you have the availability to deploy infrastructure within each and all of those regions, but just ensure that you at least keep track of what the base region you're in. Today I'm in US East Ohio. No specific reason, but maybe you would want to think about when you're actually deploying this in a live production environment, geographically where your users are going to be located, so that you could deploy it somewhere that's more geographically relevant to where they are, just for decreased latency. But anyway, that's outside the scope of this video. So just remember which region that your infrastructure is deployed in. So in this case, I'm going to be starting in US East 2, which in this case is Ohio. And another thing to know is that not all AWS services are available within each region. But things like EC2 are very standard and very common. They'll be available throughout every single region across the entire AWS ecosystem. So again, there's many ways in which we can get to the deployment of an EC2 instance, but the easiest way from the dashboard is just click to Launch Instance. So Launch Instance is going to bring us to the Instance Launch menu. And this is where we can start going through some of the parameters which we'll need to include in the launch. So name. So essentially, we're just going to need to put a name for our server, and this has no bearing on the functionality of the server itself. So we can basically name it anything that we wish, something that's relevant to you. Moodle server test. That should be fine. Application and OS images. So we get to decide which operating system we're going to be using for our deployment. Now, in this particular case, we're going to be using Ubuntu, and we're going to be using Ubuntu Server 22.04 long-term support. Of course, you can use any of the other stable versions of Ubuntu. Previous versions, such as 18.04, will also work. A lot of times, even using an Amazon-based Linux image is fine, but I find that using Ubuntu is much easier for deployment purposes, where something like using Amazon-based Linux images require a lot more configuration. So I prefer not to, and typically out in the field, you'll probably encounter either Ubuntu or Red Hat, more likely than standard Amazon AMI images. So we're going to be using Ubuntu, which is fine. We can scroll down here. It's not relevant information. So again, instance type. So instance type is just how much computing power is your specific instance going to have. So we need to select that in advance. Now, T2 Micro is part of what's called the free tier eligibility system, where you can test certain pieces of AWS infrastructure essentially for free. And I say essentially for free because that's not always the case. There's still some data and service charges that will be mounted on top of which, but the actual usage of that infrastructure will be free. But there are other associated fees that may not be. In this particular case, I'm going to go for T2 Medium. Now, for testing purposes, a T2 Micro should be okay. T2 Small should be fine. I'm going to use a T2 Medium just so that as I'm deploying this on camera, it speeds up the process of deployment, and we're not waiting for commands to fulfill to complete due to slower based system. So in this case, T2 family, it has 2 virtual CPUs, 4 gigs of memory. That should be fine for our purposes. Now, key pair. So this is very, very important. So as I mentioned about the terminal client that we would use to connect to our virtual infrastructure, we need to create an SSH key pair, right? So an encryption key pair that will be used as our mechanism of authenticating to this machine, right? Because we're going to be authenticating remotely. The instance, the SSH will be able to identify that this is someone that should be connecting to the machine based on the fact that we have the key pair, or sorry, the security key. So I've already created one called Moodle Server Key Pair, but for the purpose of this video, I'm going to create a new one. And for creating a new SSH key pair, again, it's pretty simple. You just click on the Create a New Key Pair. You can name it whatever is that you'd like, just something that's memorable, that's associated with the project that you're working on. In this case, this is going to be an RSA type encryption. Now, this is important. If you are using PuTTY, you need to download it as a .ppk format. So that's the format for which PuTTY uses. For anything else, so for MobaXterm, for if you're using the Linux-based SSH terminal client, Mac OS command client, PowerShell, you would use OpenSSH, in which case you would download it in the .pem format. If you, by mistake, download the file in .pem format, but you're using PuTTY, PuTTY actually has a conversion tool that you can convert PEM into PPK. So I wouldn't worry about it. So then you create the key pair, and it's going to download to your system. Now remember, if you lose that key pair, you effectively have lost remote access to the machine. So please do not lose that key pair. There are other ways in which you can access that that machine using the internal AWS console-based connection, but just assume that if you lose that key pair, that you have lost access or back-end access to that machine. So please keep it somewhere safe and secure. So I'm not going to create one because I already have one, which is Moodle Server Key Pair. So keep going forward. Now, network settings, this is advanced, and it's not something you necessarily need to worry about at this particular time. The one thing you do need to worry about is security groups. So around your virtual computer, so your virtual machine, your virtual server, there's going to be a virtual firewall, which Amazon calls security groups. Now, we need to create security groups that need to, at bare minimum, allow SSH traffic. And in this particular case, it's going to be SSH traffic from anywhere. Now, you can define the very specific location from which this traffic is coming from, and that would be far more secure. So if you are within an organization, you would put your organization's external IP here um, as a better standard of security. But again, unless someone has your key pair, it doesn't really matter, so we're fine. We're also going to need to allow HTTP traffic. So basically, for this firewall, it's writing an allow rule for port 22, which is SSH, and an allow rule for port 80, which is HTTP. Now, you may be wondering why HTTP and not HTTPS. Yes, in the future, you will be using HTTPS, but for the purpose of this video, we'll be using HTTP. HTTPS, configuring TLS/SSL certificates it's out of the scope of this video, but in the future you will be doing that. Now, I already have a security group created that has those ports open, so I'm going to be using that, which is Launch Wizard 1, which is fine. Storage configuration, I'm going to just up it to 16 gigs. You could probably keep it at 8 for testing, but again, I just want to make sure that nothing goes wrong during the recording of the video. So I'm going to bump it up to 16, and your GPU standard SSD drive should be fine. That's not a problem. You don't need to get anything more substantial like provisioned IOPS. That's more for high performance computing or high performance data processing. You don't need that for now. And then there are other advanced things that we don't need to worry about. Domains, IAM instance profiles, host names. We don't need to worry about any of these things. Termination protection, you can enable that, and which will basically prevent you from being able to terminate the machine, stop protection, things like this. You don't need to worry about any of this, but I would suggest that if you wanted to explore, you can explore and get a better understanding of what some of these things are. Because some of these, as you're deploying more complicated infrastructure, will become way more useful. So things like tenancy, capacity reservation is very important. Things like spot instances, or if you're running things like data processing, you can get instances for very cheap to do that for non-persistent workloads. And there's many other things. And then, of course, user data. This is one of the most useful features that you can. You could basically dump all of your Linux commands in here and pre-configure a lot of things on that server upon deployment, which saves you a lot of time. But again, purpose of this video, it's not important. The only things that are important right now: name your instance, pick your operating system, pick your instance type, generate a key pair so we can access it, and a security group that's going to give us both SSH access and HTTP access. HTTP access because this is going to be a web application, going to be accessible via web browser. We need to have port 80 open. And then configure storage. The default at 8 is fine. I'm bumping it up to 16. Not a big deal. So we can go ahead and launch. So let's launch this instance. So successfully launched. So we can go back to our instance dashboard. And so it's going to take a while to boot up here. So we'll give it a moment. And now it's running. So now it's accessible. So what we need in order to access this is we're going to need the public IP. So I'm going to copy it. Now, just a cautionary note. If you, at the end of deploying your Moodle application, decide, hey, I'm going to shut this down, for the night so that I'm not getting charged for usage on this server. So you were to instant state, you were to stop it, and maybe decide to start it at a later date. When you go to restart your instance, your public IP address may change, only because this is a dynamically allocated IP given from a pool of IP addresses that Amazon has. And why that's important is that when you're using your terminal client, you're going to want to save the connection within your terminal client so that it makes it easier for you to connect the previous time. And if the IP address has changed, naturally you're going to be sitting there wondering why you cannot connect to your machine. Bear in mind, so if you reboot or restart the machine, the public IP address may change. There is a way to give it a static IP, but again, we don't need that for the purpose of testing. Just bear in mind that when you reboot, this may change. So just keep that in mind. So again, we're going to copy the public IP address, and this is where we are going to bring up MOBA Xterm. As you can see, it's a very nice environment to work in, and we're going to go to the Sessions tab. We're going to hit SSH, and this is one of the reasons why I like MOBA Xterm so much, because of all of the options, the connectivity options that it gives you in different use cases. SSH. Within remote host, we're going to add in the IP address, specific username. So each operating system instance, in this case Ubuntu, will have a default username associated with it. For Ubuntu images, it's typically just Ubuntu. For Amazon-based images, it's EC2-user. This is can be easily looked up on the internet, so don't worry about this. But just remember, for Ubuntu-based instances, the default username is Ubuntu. Now, in advanced SSH settings, we need the private key. So we need to check use a private key. And this is where we're going to upload a file. Now again, this was the file that I created via AWS, which was Moodle server kp.pem. And I'm going to add that file. So now I've added the file, I've added the IP address and the default username. I should be able to connect to my running virtual machine in the cloud. And there we go. I am in. So we're there. We are now connected to that VM in the cloud. So now we're going to go about prepping our Linux server here and turning it or transforming it into a Moodle-based application. So here is all of the documentation that I have. So as I am going through, I'm going to explain some of the things that I am inputting just for understanding. So again, right now we have a blank install of Ubuntu server, and we need to get this to a state in which we can effectively deploy Moodle LMS on here that will be accessible via the internet effectively. So first things first, the first command we're going to be doing is sudo apt-get update. Now, for those of you that are familiar with Linux, sudo is just the ability to run commands that will require administrative privileges. Not every single command requires the use of sudo, but just for ease of use, I just use the sudo prefix command with every command as we go through. If you're wondering why every single command has sudo in front of it, but again, so first command we're going to be running is sudo apt-get update, and what this command will do is it's going to update all of the repo links, the repository links that are stored on this Linux machine. And by repository, think of a repository as effectively a warehouse of software. So you'll have different vendors which will have their own repositories, and within these repositories they will house There are specific software that will be accessible to be downloaded. And of course, every Linux install will need to know where these repositories are located. So by the command that I've just inputted, it is updated all of the repository lists so that when I'm looking for software, I do not get an error message that that the repository could not be found. Sudo apt-get upgrade is going to upgrade every repo that exists now on my system. So in one context, we were updating the links, and then a second update, we were updating all of the software packages within each repository. So with this, will it allow us to be able to access the latest versions of all the software that we need, but of course, we're not going to be using the latest versions of every single piece of software, and I'll explain why as we go. And of course, bear with me here because some of these will take some time as we progress. So if I anticipate anything's going to take longer than 10 or 15 seconds, I'm going to attempt to pause the video so that you don't have to bear silence. Okay, great. So it's defaulting and it's giving me services to restart. That's totally fine. We can skip past that. Now, the next step here, so that's just preliminary step. The next step here, creating swap space optional. So this is an optional thing. Creating swap space effectively because we're running pretty lightweight systems. Effectively, what swap space is that it's a space reserved on disk to which you can offload low priority, I guess you could say low priority processing from RAM to this area on disk for temporary warehousing, thereby freeing up more RAM space to be used for more priority based applications. So it's just a mechanism of getting more value out of your RAM if you're capped out on RAM for some reason, which we shouldn't be in this particular case, but it can still help performance. It's an optional thing to do, but I'm gonna just run through it because it's very quickly. So in this case, I'm gonna be allocating 1 gig of swap space on my disk. And again, you don't need to understand every single command. So in the first command, I was allocating that space. Second command is I am effectively, clearing out that space of any data using the dd command, which is a very dangerous command if you use it properly. And some people jokingly say that dd is short for disk destroyer, which actually can be the case if you use it improperly, because you're essentially purging or force writing data on disk, or force removing data on disk. Again, these are just some things with permissions. So I'm giving that swap file, which is going to be the file that's going to be accessing that specific location on disk, as swap space, some specific permissions so that it is accessible. Just some other commands like make swap that confirms or makes the actual swap file itself, and then swap on, it just enables it. So again, a little bit convoluted there. So we're allocating the swap the 1 gig of space mounted to this specific mount point swap file. We're using the dd command to clear a 1 gig block of space for this swap file. We're changing the permissions on the swap file. We're actually making the swap file once it's been allocated, once we've cleared the space, once we've added or corrected the permissions, we're actually making the swap file, and then we're enabling it. So we now have some swap space. Great. I don't think it's necessary, but again, it's something that's useful that you can look into that may or may not help with your performance in future projects. So next thing we're going to be doing is installing a LAMP server. So LAMP server just stands for Linux, Apache, MySQL, and PHP. So it is the base environment that's needed to deploy a PHP-based application, which is what Moodle is. So we have Linux is the environment we're currently working in. Apache is the web server that will need to be installed. MySQL is the database solution which we'll be using in this particular case, and then PHP is, of course, both the programming language slash app server that we'll be using to deploy Moodle on. So in this case, I am going to be actually attempting to add or update the PHP repositories. Now, the system should already, Ubuntu should already have updated PHP repos, but just in case it doesn't, I'm going to do it anyway, just as a safety measure to make sure I don't run into any issues here. So now I'm linked to the PHP repo, and of course I am going to again update all of those repo links just to make sure that the Linux system has everything up to date that it needs to go through the installation process. The next thing I'm going to be doing is I'm going to be installing PHP. In this case, I'm going to be installing PHP 7.4. Now, you may be thinking, well, hey, PHP 8 is out right now, and yes, it is. But in this particular build of Moodle, I'm going to be this specific build of Moodle requires PHP 7.4. Now, for any future iterations of Moodle or deployments or releases of Moodle, may be using PHP 8. So in this particular case, I'm going to be using PHP 7.4. Now, if when you go about to do this exercise, it is far later, and there are many new releases of Moodle that uses PHP 8 and beyond, please check the documentation to identify which PHP version you should be using. The concept is the same. So instead of PHP 7.4, you would be PHP 8 point what have you, right? Again, it's just going to restart the services, which is fine. Now, the next thing is I'm going to be installing a host of PHP libraries. So sudo apt install PHP followed by the version number, followed by a dash, followed by the specific library. And there's quite a few. And all of these libraries are required for Moodle to run. And the reason I know that is because when I've installed Moodle before, when you get to the installation screen or the installation part, when we're actually launching the Moodle application for the first time, it will go through and it will verify which libraries are needed for it to run effectively versus what you actually have on the system. So these are all of the libraries that are needed for Moodle to run properly. So I'm going to be installing all of those, and we'll yes through all of that. And restart services, yes, not a problem. And just to confirm, to make sure, yes, PHP 7.4, great. So I'm just verifying the version. And moving on, the next thing we're going to be doing is we're going to be installing Apache. So we're going to be installing Apache, which is going to be the web server, which is going to allow for web-based connectivity over HTTP. And we're going to be installing the MySQL server and the MySQL client. Restarting services. Yes, sir. Okay. And for good measure, I'm actually going to restart the Apache 2 service. And I am going to make sure that it's running. And yes, it is. Perfect. So now, actually, I am going to show you something. So, as of now, we have PHP installed, we have MySQL installed, and we have our web server installed. Now, to confirm that the web server is working, we can actually put the IP address in a web browser, and it should provide you with the default Apache 2 index file, which it does. So what this tells you is that the web server is working and functioning, which is good, which means we have connectivity, which is great. So when you've installed Apache and you restarted it, I would confirm that it is in fact running before proceeding. Because if it's not, nothing that which you will do after that point in time will work until you get to a point where Apache is working. So in this case it is, which is great, so we can continue. So again, we have Apache installed, we have SQL installed, we have PHP installed. Now, editing the PHP config file. So this is or was optional for older instances of Moodle, but now with more modern versions, it actually requires you to modify some of the parameters within PHP in order to get it to function better. So that's what we'll do right now. So we're going to be using the VI editor in order to do this. So sudo vi, and I'm going through the directory etc/php/7.4/apache2/php.ini. php.ini is actually the file which contains all of the PHP configurations. And so I'm going to be searching for input time right here, max input time. So that's the first parameter that we want to change. And again, if you are not familiar with Linux and you do not know how to use VI, you can use other editors. You can use Nano. Nano is much simpler to use, but I don't, me personally, I don't like to use Nano. But if you want to use VI and you're confused in how you insert text, how you save text, how you scan through text, how you search text, because essentially, effectively, you're using nothing but a keyboard. It's not a problem. You can look up any tutorial you wish. So max input time. So in this particular case, max input time is fine. Upload max file size. File uploads is on. Upload file max 20. So we're actually going to do, instead of 2 megs, which is essentially nothing, we're going to do 20 megabytes. Post size maximum. Let's see if I can do a search. Whoops, didn't want to do that. Post max size. Right there. And 21. Now again, you can think about or anticipate when you're running your Moodle app. So thinking, okay, if someone's posting information or if someone's uploading information, what are sort of the maximum parameters that you wish to set on your system, just to make sure that you maintain consistency and you don't have people uploading, 100 gigabyte pieces of information onto your system, slowing everything down to a crawl, right? That's the reason why we're doing this. So we're just giving a little bit more leeway on our system, making it a little bit more performant. So I just saved, I did a write quit, which effectively writes the file and then quits out of it. So that's done. Again, this is optional, but with later versions of Moodle, it may require you to do some tweaking. It'll actually let you know during the installation process that some of these parameters need to be changed, which is not a problem. You can go back and change it and then rerun Moodle, not an issue. Okay, so now getting into the meat of the installation. So cloning Moodle Git repo. So what we're actually going to do is, in order to actually get all of the Moodle source files that we need for the installation onto this system, we're actually going to be pulling that from Moodle's own Git repository. So Git essentially is a version control system used for managing different versions of software, used by different software development teams in order to collaborate and work on different pieces of software in a very effective manner in which they can merge changes into one another without creating any conflicts, right? So that's a gross oversimplification, but in essence, they store a lot of their recent builds on their own Moodle repo that's accessible to the public, and we're going to be accessing it in order to download all the Moodle files onto our system that we need to deploy Moodle. So the first thing we need to do is in the Moodle documentation, which I have already scanned through already, but in Moodle itself, they actually give you documentation on obtaining the source code from Git and exactly what needs to be done in order to get it to work on your system. So I'm going to save you the hassle of walking through all of this written material and just get to the core of what we need to do to make it work. So the first thing we need to do is we need to actually make a directory. So sudo make mkdir, make directory, called Moodle data. And we're going to make that within the /var directory. And we're going to make a Moodle data directory. And what that is that this is a specific directory that's required for Moodle to function, that it will actually use to store certain pieces of data / information within. So we've created that. The next thing we're going to be doing is that we're going to make sure that our web server actually owns this specific file. So this is part of the documentation. Not only does it owns a specific directory, not only this directory, but all subdirectories within it. It needs to be able to access this specific subdirectory. And in this case, we're going to allow it to own this directory so that it will have this access. We are going to enable basically open permissions on this directory. Now, I'm only doing this for the sake of speed. Really, this is probably horrible practice, and what I would recommend you do is anywhere where I'm using this command called chmod, which is where I'm modifying the permissions or the access privileges for either users, groups, or effectively anyone else on the system to access this specific directory or any other directory or file. Anywhere where I'm using chmod, I would actually go back and investigate once you've tested the deployment and it works, modifying it to the correct secure permissions, following the principle of these privilege, making sure that there's no more open privileges that don't necessarily need to be there that are there. So again, just a warning, this is probably very highly insecure, but I want you to just go back once you're done and make sure that you modify the permissions to the correct permissions that are used. Right now I'm just using open permissions just for the sake of speed so that we don't run into any roadblocks as we're installing. So that's done. The next thing we're going to be doing is we're going to be changing directory and going into the /var/www directory. Now this is something that many of you may know. So within the /www directory, that typically is the default directory for web servers. So when you, for example, that Apache page that we just looked at that confirmed that it was active. What we actually were looking at was we were navigating to /var/www/html. Oops. /html, and it was displaying this index.html file, and I'll show you, which was the Apache confirmation page. So effectively, by Apache working, what we were actually confirming was that we had access to this specific folder within our Linux system, which is great because we're going to need it. So anyway, so let's go back. So we need to be in the /var/www. Now HTML is the default folder for Apache. We're actually going to be cloning the Git repository, which was going to contain all of the cloning the Moodle repository, which is going to be containing all of the Moodle installation files, into the /var/www directory, right next to the HTML directory. And I will explain why we are going to be downloading and placing all of those files here. So as this is cloning the directory onto our system, there is something that I need to bring up in terms of this git clone command. Cloning a repository using Git, it's going to do two things. Number one, it's going to be doing what it's doing now, receiving objects. That's it actually downloading all of the object files onto your system. Step number two is what's happening now, called resolving deltas. Now, resolving deltas, what's happening is that your system, and your system meaning the Linux system on AWS, the virtual machine, is going to be cross-referencing every single object with what's called a checksum file. Which is just a mechanism for verifying that the file was not tampered with in transit and that it is as it says that it is, that we can confirm that we don't have some modified file on our system that's going to create some form of vulnerability. Now, the reason why I'm bringing this up is because resolving deltas can sometimes take an extremely long amount of time for various reasons, but typically the main reason is usually because you're using a very low performing system. So this is why I chose to opt to use the T2 medium versus the T2 micro when we were looking at instance types, because when I did this with the T2 micro, it took an extremely long time to do. So just a word of warning if that specific thing does arise. So now that we've created that, as you can see, we have HTML and we have now this new Moodle folder. And of course, we're going to change directory into that Moodle folder. And of course, I'm going to show you all of the beautiful files that are contained within this Moodle folder, which are all the files contained within the Moodle Git repo for which we've just cloned. We have everything that we need now to install Moodle. But what we're going to do, and with one of the functions of Git, is that we can actually change to different versions of the files that we have on our system to align with different builds. We can go all the way back to Moodle 13 to the latest version, which is Moodle 4.03. Which build do we want to use? Which Moodle version do we want to use? Now, I have only tested this with Moodle 400, so that is the one which we're going to be using today. So I am going to be tracking the Moodle 400 stable build, and I am going to be checking out that build. Basically checking out meaning I am going to switch to the Moodle Git instance, which contains all the files for the Moodle 400 stable version. And again, if you don't understand what that means, that's not important. You can learn what Git is on your own, and a little bit of study, and you'll be able to understand what that is in no time. But in essence, what's happened is all of these files, which you looked at before, even though it looks the same, it's actually changed. So it's changed to the version of the files that match with the Moodle 400 stable build. And perfect. Okay, continuing on. And again, I'm going to change permissions to this Moodle folder. Again, I'm using that chmod with the -r. -r means recursive, so it's doing it for every single directory, subdirectory, and file within each subdirectory. And remember, when I'm using chmod, I want you to go back and to verify the correct permissions to be using to not introduce vulnerabilities into the system. And I'm also going to change the ownership of this file to Apache. And again, to eliminate any possible issues in terms of permission issues, in terms of accessing specific files in the system, I'm going to have open permissions on the www folder. Again, using chmod, again, go back and identify what the proper permission structure should be for with these specific files. So that's done. Now, the next component we're going to be doing is we're going to be creating the database. So MySQL server is already installed, so we're going to be accessing MySQL, and we're going to be accessing it using the root account. Now, because we just installed it, there is no password on the root account, but typically when you're installing MySQL server, you want to actually enable a root password on here so that no one can just freely access the back end of your SQL server. That's not good practice, but again, the whole purpose of this exercise is just to get to a deployed state. I would go back and look through the video once you've done and go through any security considerations that you think need to be taken, and this is definitely one of them. So we're going to be creating a database, and we're going to be creating a database called Moodle. And again, this is all SQL. So for those of you that are familiar with SQL, this is SQL. You don't need to concern yourself with the specific SQL queries, but just know that we're creating a database called Moodle. And then the next query is we're going to be creating a user called Moodle user, which is going to be the root user for the Moodle with the Moodle database. And of course, in clear text here is the password. Please remember whatever password you decide to use and store it somewhere safe, because you're going to need it, right? Do not lose this. This is the password for the Moodle user, which is what actually accesses the DB, allowing Moodle to function. So that's done. And of course, we're going to need to grant this new user all privileges on all tables. And we are done with SQL. That's it. And of course, all we've done is just we've prepped a DB with a user with the proper access privileges for that user. When we go through the installation process, Moodle itself will install its own tables, its own schemas, and it will do all of that. We don't need to do any of that. We just need to prep it so that Moodle can take over and take control of the DB and do its thing that it needs to do. The next thing to do is we are actually going to need to modify a configuration file within that Moodle directory that we saw previously. And this is the PHP configuration file within Moodle. And within this, we need to input some of the parameters that we just discussed. And we need to tell Moodle that the database that we are using is MySQL I. In this particular case, as you can see by the documentation to the right, giving me some hints on what to do. The DB name is Moodle, correct? And the user is Moodle user. And the password is dbpass $. I know it's a terrible password, but again, this is about ease of implementation, not security today. So that's done. Okay, so we modified the config the PHP config file within Moodle, which is great. The next thing to do, and again, we're going to enable open permissions on that file for Moodle to access. Again, probably not the best approach, but again, go back and make sure that you understand what the proper permissions are to be used. We're actually going to be starting Apache at this point in time. And now we're nearing the end of the installation process, believe it or not. One thing we're going to need to be doing is now, as I mentioned, so let's go back here. /var/www/html is the default directory for Apache. We need to change it, and we need to change the default directory to Moodle. Because we're not trying to access the HTML folder anymore, we're trying to access the Moodle directory, which contains the actual Moodle application. And in order to do that, we need to go into the Apache 2 sites enabled default configuration file, and I know it's a mouthful, and within that configuration file, we can change the document root right here. So instead of the document root being var/www/html, var/w Moodle. And again, I'm going to write and quit. So that's done. And the next thing I'm going to be doing is I'm going to be enabling that file. And we do not need that. And I am going to, last but not least, I am going to restart Apache one more time. So now we have implemented everything we need to in order to get this working. So the next step will be is attempting to access our server, and we will see what happens here. There you go. So this is it. So right now, as you can see, we're within the Moodle directory. And within the Moodle directory, we've accessed the install.php folder. And that is the actual Moodle setup file, right? So what we're seeing here right now is we are accessing the setup for the application. And as you can see, you're going to see a not secure symbol here. And that's because, again, we're using HTTP and not HTTPS. So this is easy. So we're now at the essentially turning the corner to home base at this point. The rest is pretty self-explanatory, but we'll go through. So choosing a language, English, confirm paths. So that is correct. So that's the web address, that's the Moodle directory, and that is the Moodle data directory, and that is correct. All of those things are correct. We are using MySQL improved, so MySQLi, and you'll remember how we selected that from that option from within the PHP config file within Moodle. Of course, you can use Aurora, you can use MariaDB, but in this case, we're using MySQL. Database host is the local host, and all this means is that Moodle is connecting to the system through which it's installed on. Now, if this wasn't a monolithic application, this would change because the database host would be elsewhere. But for now, we're in a monolithic application. It's on the system. It's on the local host system. This is fine. Database name is Moodle. Database user is Moodle user. Database password is dbpass $, and you can see this is saved because I've done this before. Database port is 3306. That's the default access port for MySQL. Unix socket, you can ignore that. And we can continue. And this is what I was referring to, where it does the checks for the different PHP modules. So it's going to identify whether these are installed on the system or not. So I have most of them, with the exception of, and then it's going to give me two specific issues. And here we go. So site is not HTTPS. So we know that. We're not using the secure version of HTTPS, TLS, SSL. At some point, you will have to go back and configure this to work with HTTPS. Okay, max input vars. This is interesting. So basically what it's asking me to do is, in that PHP config file, the original PHP config file where I changed these settings, it is telling me that max input vars, which is another setting, needs to be at least 5,000, which is fine. Now, I'm not going to do that right now, but I can go back into that file. I can edit it, make it at least 5,000. I can reboot or restart Apache, and we're good. But it's just giving you some warning and some feedback in order to make sure that this runs optimally. But at least our server meets the minimum requirements, which is fine. So we can continue. And this part may take a moment. It's actually going to run through the installation process. And it's still going. We'll just give it another moment here. Okay, now it's done. We can continue. Okay, so now this is just the general user access information. So the standard user, let's just say admin, that's fine. A new password, and again, which we can choose anything. Let's just choose, I'm just going to create a password just for now for admin. I'm going to delete this instance once I've completed, so it doesn't matter. So let's do Moodle access underscore 45. See if, and just for good measure, an exclamation mark. Let's see if that passes its password requirements. And it does. Good. So admin, last name, user, sure, email address, that's fine. Let's do just a random email. Let's do Moodle email at gmail.com. Email 11. Email visibility, that's fine. City, town, that's fine. That's fine. Basically, these are just basic setup for the admin user's profile. Not super important. I'm pretty sure we can skip most of these, but just in case, let's do this. Canada, that's fine. Time zone, Pacific. America. And we can do Los Angeles, which is fine. And let's do update, and hopefully it will take all of these changes and won't be finicky about anything. Okay, so site name. Let's do, that's fine. Let's call it Moodle. Short name, Moodle, it's fine. You can put in a summary. Again, it's going to ask for localization settings. We'll just keep it for now. Manage authentication, support contact, ongoing, no reply. I think you will actually need to supply a no reply email, otherwise it will not work, but it's fine. We don't have a no reply set up for the system, but I think that should be okay. Let's see if it takes these changes without. And no, it requires a support email. So let's just add our fictitious email here, and we'll do this. Just to bypass all of these things, and we're done. And we are done. Oh, agree to the terms and conditions. So naturally, when you're doing your own installation, you'd be a little bit more considerate with those specific, configurations. But again, we've reached sort of the point of the exercise that matters, so I'm not really concerned with any of those things. Plus, they can be changed after. So this is it. So we're now in our very own Moodle instance. Now it looks very bare bones, and it's intended to do that because it's a completely customizable modular based application to which you can add external plugins, you can change the actual UI, you can add skins, you can do a whole host of things. You can connect third-party services to, but this is effectively it. You have your own learning management base system deployed. And from here, you can go and you can play around with the different configuration and customization options. This is effectively it. So that's basically it. So again, it's pretty quick, and without the commentary or my personal commentary, just actually going through using the documentation that I provide, you could potentially deploy this from start to finish in 15 minutes if you're going quick enough. And so, I would practice this a few times, go through the actual documentation, try to understand the commands that you're inputting. For things that you don't understand, look those things up. For things like Git, you may want to do like a Git crash course to understand how Git and Git repositories and version control systems work in general. Maybe you want to research Apache, maybe you want to research more into PHP. Those things can be useful. They're not necessary though. This was just to get you warmed up to the idea of deploying your own web application. So before I sign off here, some things to remember. If you are to stop your instance and restart it, you will have a change in your public IP information. Most likely, it will assign you a new IP address from a dynamic pool. At which point, you will have to go into whatever terminal client you are using, and I'm going to exit. And you are going to have to update this session because the session is now saved. It has the IP address saved. It has the user saved. It has my SSH key saved. So just bear in mind that if you restart and you go to connect, it may not work. And again, the value of having a good terminal client is I don't have to do any of that jazz. I can just double click and boom, I'm back in the server as long as it's running. So that's one thing to remember. And another thing to remember is that, again, this is just showing you start to finish of like a base installation, very, very simplified manner. There are things that you will need to consider for an actual deployment, a production grade deployment. Number one, the settings to which I use were not particularly secure. You're going to have to go back and harden that Linux server, meaning that making sure those permissions that are being used are appropriate and that are secure. Another thing to consider would be pulling the application apart into separate components. So right now we have, our web server, our application server, and our database server all combined into the same virtual machine. Typically, what you would want to do for both performance and redundancy would be to pull those components apart into different virtual machines or containers, if you will. And so I would advise that once you've done this exercise a few times, you can figure out how to do that using AWS services. And that can be as simple as deploying other EC2 instances, one that's maybe dedicated to your database. And then you just have a multi-tier application where one server contains your app and web server, the other one contains your database server, and you're just within security groups on your second server. Instead of allowing just port 22 and port 80, you will allow port 3306 open, which is the external port for a MySQL, so that your app and web server can talk to and connect to your database server, right? And you can set those different security parameters to make sure that there's validation verification that only information coming from within a specific subnet that retrieves information and writes information to a specific DB as opposed to having it being open to the public, right? So there's a lot of things to think about, but again, those are more advanced topics. Not necessary for you to understand right now. You just need to understand on a base level how to deploy this application from start to finish, which you will be able to now. So that concludes today's training video. So stay tuned for more training videos of this nature. This one was very general and basic in scope. Other videos may go into things that are a little bit more complex and specific. But with that, I'm going to end this video, and I wish you all a wonderful day. Thank you.